Hi viewer, this is EasyElimu channel. I'm Vincent Kanmwai. I'll be taking you through Vectors 2, Form 3 Mathematics, Chapter 11. We are going to start with coordinates in 2 and 3 dimensions. I abbreviate it in 2D and 3D to mean 2 dimension and 3 dimension. And remember, in Book 2 or in Form 2, we learned about representing coordinates in 2 dimensions, whereby we represented it in 2 dimensions as x, y. And remember, having this one, we said we can have them as a, b, if we have that one, and these are the positional vector of that x, y. So meaning that it can be in numbers like, for example, 6, 2, that way. Those are coordinates in 2 dimensions, whereby they are given in general as x, y. Now we shall introduce 3D, and before that we are going to see that in 2 dimensions, remember we had to draw this one on a Cartesian plane, and we had coordinates being given on a Cartesian plane of x, y, if you remember well. And this was given on this Cartesian plane. For example, you can have some coordinates having up to a given number. For example, a coordinate like, say, you can have a coordinate at this point here, and you will have that coordinate there, let's call as a, point A, and that point A being given by, in 2-dimensional coordinate, it will be given by 4, actually it's 3, 4, so 3, 4, it's given by 3, 4. That is how we do give coordinates in 2 dimensions, basing on x-axis and y-axis. Now we are going to introduce another coordinate, another dimension, to make it to be 3 dimension. Actually, if we had 2 axes of x and y, we shall introduce another axis today, which will help us to give a coordinate in 3 dimensions. So that axis which we shall introduce is called an axis of z. So it is z-axis. And in order to use that, we are going to make this one be on the base side such that we shall have. So in introducing the other coordinate, this is what we do. This coordinate of y and the x-axis are taken as the base such that in case we had a point here, let's give it as this. In case you have that point and you have a point at this point here, let's call this point A, and this is 1, 2, 3. You can give the coordinates of point A in 2 dimensions using this one, if this is x-axis and that one y, as 2, 3. A can be given by 2, 3. The same can be given to coordinate like, let's say, another one like here. So that one be given B. And you will say B is given by coordinates 5, 6. That is how we do give coordinates in 2 dimensions. But if we introduce another axis such that the coordinate, another coordinate may be in this post but is not on xy plane, then we needed to introduce another axis here such that that axis will be called z-axis. In redrawing it to make it much more visible, let me draw it. So we shall have a box which I'm drawing here, and this is x, this is y, and this is z coordinate. So instead of using that, let's use here where this one are numbered 1, 2, 3, 4, 5, 6, let's say with 7, and that is y, and this one is for x-axis. So for z, it's going upwards direction. So you will find out that in case you want to find a coordinate here on x-axis in 2 dimensions, then you will only base on the xy plane. We have seen how you can give a given coordinate in 2 dimensions. Like here we have seen that one, like of A, B, and C. And here the same can apply if we have that A here. But we can still give that coordinate of A in 3 dimensions, where z now, for this case at this point, will be equal to 0. Now we are going to see the columns and position of vectors in 3 dimensions, and another that we remember in Form 2 we learned about how we can represent a 2-dimensional vector in a column way or in a column vector, whereby we had, for example, having a vector x, y. This one here is represented in column or written in column, or it will be a column vector. It's written in column vector or a column. If it's a vector, then it will be a column vector. But if it's coordinates, then are a column coordinates of a given point. So here we are going to introduce another one in 3 dimensions. This was in 2 dimensions, so we are going to introduce that of 3 dimensions. And in 3 dimensions, we may be given certain issues. For example, if we deal first with the column and position of vector in 2 dimensions, we shall find out that if you need to find the vector in 2 dimensions, for example, let's say the displacement of a given point, we may take a point which was at a point, let's say 4, 2, was displaced from 4, 2 to a point, let's say 2, 1. If you want to find the column vector of this point here, these are the positional vectors of that point. So, positional points or coordinates of the point where it was displaced to. So, if you want to find the positional vector of this point, you will find out after finding the column vector. And in order to find the column vector of this, you need first to change this positional coordinates into column coordinates. So if we change them to column coordinates, you will find out that to find the displacement here, displacement will be given by taking the difference between the two. So we arrange them in column coordinates. It is 4, 2. These are the coordinates of the given point which was changing. And then whatever we shall be subtracting is the displacement, and that is the vector to which that point was moving to. So we shall have 4, 2, 1. So that is how it is done. And this one is the same as taking 4 minus 2 and 2 minus 1. And whatever we shall find is a positional vector, it's a column vector actually, and it will be in position of 2, 1. So this one here, what I'm found is a column vector. This is a column vector, but in 2 dimensions. So if you want to find a positional vector from there, you will write it as 2, 1. That is what we do have. But we can change it to be in 3 dimensions. And in 3 dimensions, we can have some of them several. For example, we may have an example. Let's say a point A has been displaced from 3, 1, 4 to a point B, which has the positional coordinates of 7, 2, 6. And we are being asked to find, or for example, you can represent this in positional or column vector. Let's represent them in a column vector. Since these are the positions of that point, it was at a position A with 3, 1, 4, but was displaced to a position B, which is 7, 2, 6. So we can find that vector in which it moved. So that one will be displacement. And if you find that displacement, you will first write this positional coordinates of this A and B in column coordinates. And if you write in column coordinates, you will find that we are going to find the displacement, and displacement will be, you take displacement of B, that is B minus A. So we shall take B minus A. And if we do that, we are going to have 7, 2, 6. If we write them in a column way, so it will be 7, 2, 6. minus, we are going to minus that of A, and that is 3, 1, 4. So if you do that, it's the same as taking 7 minus 3. We are subtracting the corresponding values in X, Y, Z direction. So it is 2, 1. And this one is 6 minus 4. And if you do that, you will get, here we are going to get 4, 1, 2. Whatever we have found here is now what is called column vector, in which A was displaced to B. So that is the column vector of displacement. So that is what we give us in 3 dimensions. So in general, we can say that a column or position of vector in 3 dimensions is given in terms of P, Q, R. If you find a column vector given in 3 dimensions, you will find it being given in that position, that is P, Q, R. And this one here, P here represents in X direction. P is always in X direction or X axis, so it will be X direction. Q is in Y direction. This one is for P. Q is in Y direction, and R always faces in Z direction. So meaning it is giving us a 3-dimensional vector. So from there we can find out that is how we can find column and position vector in 3 dimensions. So we shall look at addition and subtraction of vectors in 3 dimensions. So let's go on and see some of the examples, and also using some of the scalar to multiply in 3 dimensions. So an example we have, if A is 1, 2, 3, B 4, negative 4, 5, C 1, 0, negative 5, find what is A plus B. Let me write first. So if A is given as 1, 2, 3, B is given by 4, negative 4, 5, and C is given by 1, 0, negative 5. So you are being asked to find A plus B minus 2C, B 3A plus 7 over 8B plus 5 over 6C, and C 3A minus 2B plus C. What we have here will help us or guide us to work out the given sums here. And remember, if you have a column vector or a positional vector in 3 dimensions, if you take a scalar multiple, for example, if it is PQR, and you multiply it using a scalar quantity outside, then whatever you will get is the same as KP, KQ, KR. That is what you will obtain. And in case you are doing subtraction, we have seen in terms of displacement how you do. If it is, for example, you have P, Q, R, you are subtracting X, Y, Z, you will find that your value will be P minus X, Q minus Y, and R minus Z. That is the answer you will obtain. But in addition, you will have, if you have P, Q, R, you are adding to X, Y, Z, then your value will be equivalent to P plus X, and this one will be Q plus Y, Z plus, actually R plus Z, in case you have the coordinates in that term. So that is how we do work out with the 3-dimensional vector. So here we are going to use whatever we have been given to work out. I will work some of them out and others I will give you to work out. So we are going to work out if, for example, I will start with this A, and for A we are just having A And A here we are having, for A, we are having 1, 2, 3. We shall add, because we are adding to B, and B is, add B, which is 4, negative 4, 5. Then we shall subtract 2, but that 2 is being multiplied by C, and C here we are having 1, 0, negative 5. So it's 1, 0, negative 5. So this one is the same as, if we do the first one, you shall find 1 plus 4, you are going to have 5. 2 plus negative 4, you will have 2 minus 4, and that one is negative 2. 3 plus 5, you will get is 8. So that is for the first bracket, is this one. And here, if you do this, you are going to get minus, but here, 2 by 1, you will get 2. 2 by 0 is 0. 2 by negative 5, you will get is negative 10. So you are going to subtract that. And after doing that, you will find 5 minus 2 is going to give you 7. 5 minus 2 is 3. Negative 2 minus 0, you will have negative 2. 8 minus 10, you are going to have 18. So that is how we do find in terms of addition. So remember that if it is 3A, you will multiply as I have done here. The first thing you multiply. And if it is 7 over 8, you just take, let me do for 1 for fraction. For this fraction here, then it will be 3 into A, and A you are being given 1, 2, 3. And then we have 7 over 8 of B, so it will be plus 7 over 8 of B, and B is 4, negative 4, 3, 5. Then we add to 5 over 6, and that is of C, 1, 0, negative 5. So that is how it's done. So if we do simplify here, or open the brackets, we shall find 3, 1, we are going to have 3, 6, 9 for the first one, plus this one here will give us, you are going to have 7 over 4. This one will give you negative 7 over 4. And this one, other one will give you 7 over 40. If you open, and here you will have 5 over 6 multiplied by there, you are going to have 5 over 6, 0, and then negative 25 over 6. So after doing this, I will leave this one for you to add, in that you will take 3 plus 7 over 4 plus 5 over 6, you find the value. The same apply to this, you find the value. The same to 9, 9 plus 7 over 40 plus minus 25 over 6. So it is like 9 plus 7 over 40 minus 25 over 6 will give the answer. Here, remember we have a negative here, so you do it out and you give your answer out. That is how we do add or subtract. In case of subtraction, you shall do it out. So I'm leaving this one for you, and also for this subtraction, the other sum C for you to work out. That is how we do compute given vectors in 3-dimensional and how to add them in 3-dimensional together with subtraction. Let us move to column vectors. In terms of unit vector, I, J, and K. And here we are going to see, in form 2, remember we did a unit vector in X direction and Y direction. And remember, a unit vector in 2 dimensions, in form 2 we do say that in X direction we had as 1, 0, and in Y direction we had as 0, 1. These two vectors here are two positional vectors in 2 dimensions. We did say this one here, it has a unit magnitude. Unit magnitude, I think you understand by the term magnitude as we did in form 2, and this one also has a unit magnitude, where the origin is 0, so they are moving from 0. So this one here, the y-axis here is 0, but x, the value of x is 1. So it is along the x-axis, this one is along the y-axis. where with the 0 or y at 0, y equals to 0 here as the origin, and here x equals to 0 as the origin. So they are in that respective given group. So we are going to introduce another one of 3 dimension, and in 3 dimension, a unit vector in 3 dimension will be given by, for this case x, we have seen in 3 dimension we are introducing z. So in x, y, z, if we need to give it in x, y, z, we are going to have 1, 0, 0 in case of x. If we need to give in case of x, then we shall have 1, 0, 0 for x axis or x direction, and then for y direction, that's in y direction, we shall have 0, 1, 0, that is in y direction, and we are going to have a unit vector in column way. In z direction, we are going to have 0, 0, 1. So that is what we have. On a Cartesian plane, we are going to have, if this is the z direction, this one the y direction, and this one is x direction, then we shall have, if we have a unit vector each, we shall have the first one will be at that point, that is 1, second here 1, and here 3. So if we give this one as A, this one B, this one C, then we can say the value of A is 0, 1, 0, and that of B is given by 0, 0, 1, and C here, we are getting C as 1, 0, 0. So what we have here is what we are referring to as positional column vectors of A, B, C in unit direction. So they will be in unit direction. This one can be represented as, instead of that one, we can say it is I. I is normally in x direction. So in case to represent that of C, will be given as 1, 0, 0. That is for I. And for J, we have J and K. So for J, it is in y direction. So we shall be representing that of A. So that is 0, 1, 0. And for Z, we shall have K direction. So it is K will be equal to 0, 0, 1 in Z direction. And that is how we do represent them as unit vectors in x, y, z direction. So they are represented by I, J, and K in respective direction. So we shall look at an example here, which can help us. For example, you have been told express vectors 5, negative 2, 7 in terms of unit vector I, J, and K. So we have, let's say A as 5, negative 2, 7. So you are being asked to represent that one in terms of I, J, and K in unit vector. So remember, in terms of I, J, K, we have seen that is how we do represent. So if we need to represent this in that direction, then it means A will be equal to 5 in, that is 5 in x direction. So if it is in x direction alone, it will be on x-axis we shall have 5, 0, 0. If we want to represent it in a unit way, we shall first take that way, and then we add 2. Now the other one will be having 0 in x direction, but negative 2 in y, and 0 in z direction. And if we add to another one, which is remaining now 0, 0, 7, which is 7 in z direction, we shall have what we have there. So that one, we can still represent them in terms of I, J, and K, and say that one can be represented by 5. Now that 5 can enter into, or if we make this number 5 here to be in place of 1, we shall now factor out 5, and we have 1, 0, 0, such that we need 1, 0, 0 there. And if that is the case, we are going to have negative 2 here, so it will be negative 2, but here will be 0, 1, 0 inside. In case we multiply, we shall get what we have there. And now for the z direction will be plus 7 into 0, 0, 1. So that is what we are having. But remember, what we are having here as column vector in unit direction, we are having this one we have said is equivalent to I. The other one here, which we have here, is equivalent to J, and the other one equivalent to K. So we can still write that one as 5, but in place of this we place I, and then will be minus 2. In place of what we have here, 0, 1, 0, we shall write J. The other one will be 7, but in place of that one, what we have here, we can replace with what looks like that, which is K. So we are going to have this one in terms of I, J, and K, we are going to have as 5I minus 2J plus 7K. So that is how it is represented. So if you are being asked to give or write in terms of I, J, and K, and you are being issued with a column vector in 2 dimensions, then that is how we do give it. So we shall give a general comment on it. In general, if you have A, B, C, then this one can be represented in terms of I, J, and K as AI plus BJ plus K, actually CK. And if it is in 2 dimensions, this is in case of 3 dimensions. If it is in 2 dimensions, then you have AB. You will have this one represented as AI plus BJ plus, actually the Z direction is not present, so it will remain this way, and this one is given in 2 dimensions. So that is how we do represent them. In case you have been given in any kind of dimension, I think you are now capable of writing them in terms of I and J. Next we are going to see how we shall be finding out given magnitude of vectors in 3 dimensions. But before that, we shall look at an example containing this one here. We shall consider given R equals to I plus 2J minus K, S equals to 4I minus J plus 2K, T equals to 2I plus 3K. Now find R plus S plus T if all have a common origin O. So we shall do that. If you want to find, we need to find R plus, actually we have a R plus S plus T, and B R minus 3S plus T. What I will do here, I will do the first one. The second one you will have to help. But remember, a scalar multiple is just doing the same as we did for the earlier one in previous session. So here I'm going to tackle the first one here, A, and there I will write the way I have the multiples of I. So R here I'm having I plus 2J minus K. Now that one I'm going to add to S, and S I'm having as 4I minus J plus 2K. After adding that, I'm going to add another one which I have as T, and T has been given T is 2I. But remember, we have this one in 3 dimensions. This is not in 2 dimensions. It is in 3 dimensions because we have K present and I. So meaning the value of J is 0. So you can even still write, in order to avoid confusion, 0J and then plus 3K. So meaning the coefficient of J there is 0. That's the reason why J is not written. So if that is the case, we shall find that A is equal to, which is A here. So we will find out is, now we shall add the corresponding values of I, or we shall collect the like terms, and we shall have I plus 4I, we shall have 5, plus 2I, we shall have 7I. So we are going to get 7I, then we shall add 2j minus j you shall remain with j, plus 0j you shall have plus j. Then the other one will be minus k plus 2k, you will have k. K plus 3k, you are going to have 4k. So it is plus 4k. So that is the answer which you will find after adding them together. So that is how we do add up or sum up. We only sum the corresponding values or coefficients of the given values. For example, if it is I, j, k, we only add the corresponding coefficients. So here, for 3s, you shall now, this is a scalar multiple, so you will multiply by the vector inside, which is s, and after multiplying, you add as we have done. If it's subtraction, we subtract, and if it's addition, you do the same. With that, we have come to the end of that. Let's see how we can find a magnitude of a vector in 3 dimensions. And remember, in Form 2, we did learn how to find in 2 dimensions, in that if you have xi plus yj, then this one can be found by taking the square root of x squared plus y squared. So instead, finding the magnitude of a given vector is like finding the modulus of that vector or the length of that vector. So this is how we do find it there. So we are going to consider how to find the magnitude of a vector in 3 dimensions. We are going to consider the given cuboid there, whereby we shall have a, actually let's start with the inside, that is A, B, C, D, E, F, G, and H. So having that, let's consider 0.435, and in this case, so at this point we take it as 0. In 3 dimensions, we know there will be 0, 0, 5. Here will be 0, 0. I think that one you know, because it is the origin of every of the x-axis and y-axis are also z. So here in the x direction, at this point here, we are going to have 4, 0, 0, because it is the x-axis. And at this y, when it joins, this one will be our 0, 3, 0 at that point. And at the point here, where it is on the xy plane, it will be 4, 3, but in 3 dimensions, we are going to have 4, 3, 0. Up here, we are going to have, because it's in 3 dimensions and it's up of the 4, 3 in z direction, it will be 4, 3, 5. That is the point now. And here we are going to have 0, 3, 5. Here we shall have 4, 4, 0, 5. So that are the point. So in case we have been told to find the length of AF, the length of AF. If you want to find the length of AF, then here the first thing you need to do, remember you have to join line A to C in order to find that triangle. After finding the triangle of A to C, after that you calculate the length, you calculate that of AC first. After getting AC, then you will use that AC to calculate the length of AF, of which will be from this section here to F, from A to F. So it is a triangle, a right angle triangle. So you will find the base here will make a 90 degrees. So you will have a right angle triangle. First, we need to find AC. And to find AC, we need to find first AC. And AC will be equal to, because it is vectors, we shall move to AB. Then you move to DC. And if you move to AD is 4, 0, 0. first plus that of DC is actually in y direction, so it is 0, 3, 0, 3, 0, 3, 0. That is the reason why you find AC there is equal to 4, 3, 0. So that is what we are having as AC. So that is the value or the coordinates which you will determine AC. So having that, we can still find out. And if we want to find out now this AF will be found in case now we have this, we have the other one. We can find AF, and to find AF you can use with the determinant in Z direction. So we are going to find AF will be given by, we first find the coordinates of AF. So will be given by AC plus, remember this one was AD plus BC. So this one will be AC plus CF. And that one is going to give us 430 plus CF. CF is 005. So we shall have 435. Now this is now our AF. But we need to calculate the length of AF. Remember, if you have in this direction, it's like writing in terms of unit vector. You will have AF equals to 4i plus 3j plus 5k in terms of unit vector. But if you want the length of that one, then the length can be calculated by finding the magnitude of that given value. So in case to find the length or AF modulus, abbreviated as that, if you find a symbol where you have abbreviation of AF modulus, then know that one, they are asking for the length of that given abbreviations. So it will be equal to, now you will take the coefficients in x direction squared plus y direction squared, and then the coefficient of z direction squared. So it will be x squared, which is now 4 squared plus 3 squared plus 5 squared. And this one you are going to get is the square root of 4 squared, you will get 16 plus 9 plus 25. So if you do that, you are going to get, that one is going to give you 50. That is 50. So you are going to get square root of 50. So we are going to have, let me have right here. So AF modulus, we are getting as the square root of 50. This can be still written as square root of 27, or let's say 25 by 2. It's 25, actually 25 by 2. And that one is the same as writing is the square root of 5, is actually 5 root 2. So AF there can be given by 5 root 2. So the length of this line from A to F is 5 root 2. That is what we obtain by calculation. So that is how we do find the modulus. If you have in 3 dimensions, you do take the coefficient of I, you square, the coefficient of j, you square, and the coefficient of k, and then you square. If you find the value, find the square root, you will have found the modulus or the length of that given value. Now I want you to calculate the modulus or the length of line BE. Draw it yourself, then after drawing, calculate the length of line BE. Now I want you to calculate from B to E. E is present here, so you will find BE, and BE is with the cut of that line. So it is from B, D, E, and then B. So we are having it as a right angle triangle, but vertices are B, E, and D. So calculate the length of E, B, the way I have done. With that, we have seen that. So we are going on to see some of the examples which we may use it to calculate so further. Now we have, given that P is 2i minus j plus 2k and Q is I plus j minus 2k, determine 2p plus 2q, or the modulus of 2p plus 2q. So what we shall do, I write down P, that is 2i. You will determine the modulus of P and modulus of Q, because I remember I have shown you the way. I will do that of 2P plus 2Q, the modulus of that. So in that case, I'm going to have 2 into P, but my P is 2i minus j plus 2k plus 2 into Q, and my Q is I plus j minus 2k. If I do that, I'm going to have 4i minus, now this one will be 2j plus 4k plus this one will be 2i, I'm opening the bracket, plus 2j minus 4k. If I do that, I'll now collect the like terms, and if I collect the like terms, I'm going to get 6i, then this is 2 plus 4 plus 2 will get 6, negative 2 plus 2j will be 0, and plus 4k minus 4k will be equal to 0. So we are having plus 0j plus 0k. So that one is the same as writing 6i. So 2p plus 2q modulus actually is going to give you, we say you find the square root of x squared plus y squared plus z squared, of which these ones are the coefficients of I, j, k respectively. So if that is the case, we shall have 6 squared, square root of 6 squared, and that one we shall add to 0 squared plus 0 squared is just 0, so it is 6 squared, and you will find the length of that one, or the modulus, is equal to 6. So you will have it as 6. Now you will work out that modulus of P and also work out that of Q. That is how we find it. The other one I gave you will be, now you will add another one. That one you will try to work it out. Find the modulus of that one. Then with that we have come to an end of magnitude of a vector in 3 dimensions. Next we are going to see parallel vectors and also collinearity of that vectors. So there we shall start with the parallel vectors. And the parallel vectors, we will understand that if 2 vectors are parallel, then one must be of a scalar multiple of the other, in such that if, for example, we are having vector A, which I may denote it that way, being parallel to vector B, let's denote it by B that way, then this implies that this will be only parallel if A is a scalar multiple of B. That is, B is a scalar multiple of A, such that when you take A, K multiplied by B, you will get A. Whereby this one, K here, is a scalar multiple. And parallel vectors are such that you will find out, for example, on drawing, you may find out you have certain vectors, they may be that way, let's say up to that point. You will find even that one is in that case. You will find this one may be A, this one may be B. These 2 vectors can only be parallel if they have, like, one is a scalar multiple of the other. And in case of, for example, if it's a function and it's of a vector on a graph, you will find out that they will only be parallel if and only if they have the same gradient. If and only if they have the same gradient. That one will be only if you are using a Cartesian plane, and it's a function of vectors which are parallel. But for our case, we are going to consider vectors parallel but having the same coordinates of positional vectors. We shall look at an example to indicate the parallel of vector, and we shall look at example A, which says that we have two sector of vector, that is 4, -3, -12, that is A, and they are actually in 2 dimensions, and B, I'm having -12, 9. These are in 2 dimensions. These two vectors can only be parallel if one is a scalar multiple of the other. So we shall do that and find out if that is the case. So we shall, on doing, let's say that A be a scalar multiple, B be a scalar multiple of A, such that we take K. But to find that, what you do here, you take the coefficients of X in. For example, if we want to find that A is a scalar multiple of B, then we shall take the coefficients of X in B, for example. That is X in B. We divide the coefficient of X in X, coefficient of X in A. This should give us the same as taking the coefficients of Y in B divided by coefficients of Y in A. Such that what you will find out is what we call K. That's how we do it. So let's see if that's the result. Take -12 over 4. You will find your value is -3. And if you take 9 for YB, 9 over -3, you are going to find out this one is going to give you -3. So meaning that that is our K because it is similar in both. So K is equal to -3. K is equal to -3. So that means that if you take B, actually if you take B, you divide by A, you will get K. So meaning if you take B, you divide by A, is going to give you K. Meaning that B is equal to Ka. So K is a scalar multiple there, and A is a scalar multiple of B, with it being K is -3. So meaning that B is equal to -3A. That is what we found out. If you take -3, you multiply by A, you will get out B. So this one means the two vectors are parallel. Actually, A and B are parallel. The symbol for parallel, we just draw that two line there, as you can see them. So that one means they are parallel. Next, when you will do this, I want you to verify that -6, I'll give you one, that is an exercise. -6 and -4, that is for C, -6, -4. And 3, 2, that is for D, is 3, 2, and C is -6, -4. Test whether the 2 points there are parallel to each other. If they are not parallel, then you will find that none of them is a scalar multiple of the other. So you will find out if they are parallel, then one of them will be a scalar multiple of the other. So in general, if you work out and you find that after working out, whatever you find, one of the vector is a scalar computation of the other, then we say the two vectors are always or are parallel. But if you don't find so, then it means they are not parallel. Let's now test collinear points or see how they appear. And in collinear points, you will find that in order to test collinear points, the points must be on a straight line. And if they are on a straight line, they should satisfy two conditions which are necessary for them to be qualified to be collinear points. And this condition is that one must be, actually the points which are to be tested must be parallel to each other. And one of the points there must be common between the points being tested. And to be parallel, you will find that in case you are having A, B, points A, B, and C, then for them to be collinear, for our case, we are going to test 3 points only, that is 3 vectors. So you will have that of AB will be equal to, actually if you want to test, you will take AB should be parallel to BC, which will mean that means AB should be equal to KBC, whereby K is a scalar multiple. So in that case, we can observe that B here is common between both of the 2 points. That is, B here is common. And if we have that, then we will have satisfied the condition of collinearity. So B is common point, where K is scalar multiple, as we can observe. So we are going to see some of the examples, both in 2D and in 3 dimension, and view out what will result in later. In 2 dimension, if A is, we are looking at an example and we have if A is 0, 3, B is 1, 5, and C is 4, 11. We need to find out the collinearity of the points. And if that is the case, we shall now find AB such that AB should be KB of C. That is a scalar multiple of BC. And if that is the case, then it means AB is the same as taking B minus A in order to find that. And we shall have, if we do that, we are going to have B, the corresponding ones will be 5, 1, 5, minus 0, 3. This one is going to give us 1. 5 minus 3, you will get 2, so it's a half. And that of BC is C minus, actually is C minus B, and that one will be 4, 11. And then we are going to have 4, 11 minus that of B, 1, 5. This one will give us 4 minus 1 is 3. 11 minus 5 is 6. So that's what you have. So meaning that if we work out, we are going to get that we shall have AB being a half. So AB is a half. And that a half should be equal to K multiplied by 3, 6. If that is the case, then we shall have the corresponding ones and say, this is what we have here. So it will be K a half, that's not a half, is 1, 2, is equal to 3K and 6K. So that is what we have. So if you compare the coefficient, you are going to get that K will be equal to 3K is equal to 1, so meaning K equals to a third. The same applies to the next one. We are having 2 is equal to 6K, so meaning that K alone will be equal to, if you divide, you are going to get K equals to a third. So K is a third, K is a third. So we have found out that K there is a third. So in both cases, K is a third. So we shall say that AB is equal to a third K a third, because K is a third, so it will be a third BC. Now that one has satisfied the first condition, which that they should be parallel. So meaning that AB is parallel to BC. And if that is the case, we can observe that this point here and this one is common. So B is a common point. B is a common point. And if that is the case, we can say that the 3 points are collinear. The 3 points are collinear because one is a scalar multiple of the other and B is common between them. So we can say that is how we do calculate it. And it can also be calculated in another way, in that you take maybe even AC and BC will still give you the same value. You can decide to use that method and you will find out the same value. That was in 2 dimension. Let's check in 3 dimension how to find collinear points of a given point. So let's test and see. Now we are going to test in 3 dimension, and that is, we are going to test if we are having A, B, and C again. If A is 135, A 135, B 41220, and C is 3915. Test whether the 3 points are collinear. If they are not collinear, they don't satisfy the condition which I have given out earlier. But if they are collinear, they must satisfy that condition. So we shall test and assume that they are on a straight line. So if we assume that, then we shall say that if we take AB should be equal to KBC, where B here will be a common point. So we can either take that, or someone may decide even to take another route, whereby he will say AC is equal to KBC, such that C is the common point between them. Still will give you the same value. Actually will give you whatever you want, even if K will not be the same. So here we shall do that, and we shall find AB here. AB will be B minus A, and this one will be equal to B. We shall write them in a column vector, and writing them in a column vector will give us 4, 12, 20. We shall subtract A, and A is 1, 3, 5. And on doing that, we are going to have 3. This one will give us 9. 20 minus 5, we are going to get 15. So that is what we are going to have. Then BC is the same as taking C minus B. If you have 2 vectors together as this, you take the next, or the vector on the right hand, you subtract the previous one in order to get what you have. So that one is C minus B, and you will have, that is C is 3, 9, 15. 3, 9, 15. We write them in a column vector. After writing that one, we also write that of B, which is 4, 12, 20. And if you subtract, you are going to get, this one is negative 1. This one here is going to give you negative 3. 15 here, negative 5. So that is what we shall have. Now we have found AB, we have already found BC. Whatever we are remaining with is only to find K. So AB here is 3, 9, 15. And this should be equal to KBC. And our BC here, BC is -1, -3, -5. So -1, -3, -5. And if you do that, you're going to get your K from that given point. So if that is the case, we shall find out that if you open the bracket, you will have this one here unknown. I'm extending it out, so I'm opening the bracket. It will be -K, -3K, and -5K. That is just the extension. So it's like 3 is equal to -K, 9 is equal to -3K, and 15 is equal to -5K. Now let's find the value of K in each case. So in each case, we are finding that each case implies K is equal to -3. So we have found that K is common between both of them, and thus K is our scalar multiple. So meaning that here AB is equal to -3BC. So we can replace that one by -3BC. So we have found K equals to -3. From there now we can say, since we have that, B is a common point between the 3 points. B is a common point. So we can say this one here, what we have found is that AB is parallel to BC. Now we can say AB, vector AB, which is denoted by capital bold letter, AB is parallel to BC. Since we have found AB, since AB is equal to a scalar multiple which is -3BC, and B is a common point between the 3 points. So meaning that they are collinear. So the 3 points are collinear. That's how we do find. And you will use that method to find any, or to show any points that are 3 points are collinear. So you can still use another method, which is A, C, and BC. Since I have worked out using this method, you are required to use the other method in order to prove if you will find K similar in both of them. And if you use AC and BC, you will find that C will be a common point. So that one I leave for you to work out or to handle that one. And from there, we are going to see an example. We are going to handle a triangle and find out the given points if they are collinear, in case we are being asked one. So we are having a triangle OAB. I shall draw the triangle here. That will be my triangle, so I will have O, A, and B. So it's such that a triangle OAB is such that OA is equal to small a, OB is equal to small b, and C lies on OB such that OC to CB, that is the ratio of OC to CB, is equal to 2 to 1. And D lies on AB such that AD to AB is equal to 1 to 2. And E lies on OA produced such that OA to AE is 3 to 1. Express the following in terms of A and B. That is OC, OD, OE, CD, DE, CE, and then show that CDE are collinear. So what we are going to do, we are going to write down that triangle as given below. So that we have drawn, so that OA here we have been issued with OA as small letter OA. And if we have been told it's OA, then it means the arrow should go that way to indicate that the vector moves in that direction. If you move the other direction, then it will be negative a. That is the rule with the vectors. You only consider the positive direction. So meaning if you move back, it's a negative. Then OB is B. OB here will be B. The same applies. So the vector of OB moves forward from O to B. If you move back from B to O, it will be negative B. C lies on OB. C is a point on OB such that the ratio of OC to CB, ratio of OC to CB equals to 2 to 1. Ratio of OC, let's say that OC be a point at this point, and this one we call it as C, such that OC to CB is 2 to 1. So meaning this side will be 2, this side will be 1. That is the ratio which we have been given. So CB will be 1 of that. So meaning if you are calculating, we shall see how we shall find out. Then B lies on AB such that AB, the ratio of AB to DB is equal to 1 to 2. So D lies on AB. D lies on AB. D lies on this AB. So that the ratio is in the ratio of AD to DB is 1 to 2. So meaning that if D may be at this point, we may have letter D at that point, such that AD to DB is 1 to 2. So from A to D will be like 1 and D to B is 2. That is what they are referring with the 1 to 2 in case it's AD to DB. So that is how is it. And then we have E lies on OA produced. OA produced such that OA to AE is 3 to 1. So let's draw that. We have OA produced, so I'm producing this one here. Remember in chords, that is circle, chords and tangent, we learned how to produce a line. So I'm going to produce OA in that way. That is OA produced. But we know one thing, we have been told that it is in the ratio that OA will be 3 and AE to AE, let that point be E. So if that point is E, then we shall have OAE, so that OA is 3, AE will be 1. That's the ratio which we are being given. So if that is the case, express the following in terms of A and B. Express in terms of small a, vector A, and vector B. Now we need to express what we have. So we have been given the first one as OC. So I shall start with the OC. We need to express OC in terms of A and also B. So if that is the case, OC here, which is here, as you can see, will be given by, since we have said this is a ratio 2 to 1, then it means this side OC will be equal to 2 over the total ratio, because from O to B is small b, that is vector B. So meaning that the total ratio will be 2 plus 1, you will get 3. So if you want to express that, will be 2 over the total ratio, then multiply by the total vector of that given line. So it is B, vector B. And that is OC. That is how we do express OC. Another one is OD. To express OD, meaning we shall join B to O. We shall join D to O in that way. Then to express OD, you can express it in two ways. First, you can express OD by taking OA plus AD. That is OA plus AD. Will still give you the same as expressing it in a second way. And second way will be, if you want OD, you can still use the other route. Actually, vectors is just like circumnavigating or just using certain routes in order to arrive at the same destination. So we are looking a way in which we can arrive from O to D using another direction. So it is one we have said you use the OA AD, or we use OB and then we go to BD. So that is OB plus BD. Any of them will give us the right way because we shall be arriving at the same destination. Let's choose one of them and choose OBBD, or just do them all. So we shall find OD is equal to OB. But OB we were given is vector B. BD is 2 over the total ratio, which is 3 of BA. And remember, BA can be given by taking BO plus OA. So it will be negative B plus A. So that is A minus B. So that is what we shall find. And if you do that, you're going to get B plus 2 over 3A minus 2 over 3B. This one here will give you 2 over 3A minus, actually it's plus, that one is a third B. So that is what we have. So we have found, we shall write them here, maybe they will help us later. So OD is equal to 2 over 3A plus a third B. They will help us later. Then next is find OE. OE as 3. We can find OE by taking OA plus AE. Actually, OD can also be found in another way. So we can still use the other way here, and that is OA, which is A, plus, I'm just showing up that you will just arrive the same formula. So that is OA, which is A, vector A, plus 1 over the total ratio of the vector, that is 1 over 3. So we shall take 1 over 3 of line AB, and line AB is AO plus OB. That is negative because it's against the vector, negative A plus B. So that is B minus A. So you will have, that one will come and give you A plus a third B minus a third A. And if you work out that one, A minus a third A, you'll get 2 over 3A plus a third B. Still getting the same value. No matter what route you take, you will always arrive at the same destination. The same applies to OE. In order to find OE, you can still use OA then plus AE, or just use OB plus BA plus AE. You will still get the same value. So in this case, let's use for OE, take a shortcut, that is OA plus AE. And if that one is the case, then we are going to have OA we were given was A, vector A. And AE here, we were told the ratio of OE, the ratio of OA to AE, we were given as 3:1. 3 here is representing A. So we need to find what will 1 here represent. If 3 represents A, that is 3 represents A. Then what about 1? You will find 1 will represent times 1 over 3. And you find this section here is going to represent a third. So meaning that AE is a third of vector A. So we shall add a third of vector A. And in that case, we are going to have, this one will give us 4 over 3A. And that is the value of OE. So we are going on and find out CB. Let's find CD. CD is present here. So we are going to join C to D. We have joined C to D. So we need to find CD. And finding CD can be found in 2 ways. One, we can either move CO, then we add OD. That is CD is equal to CO plus OD. Or you can go CB plus BD. You will still get the same answer. Or this is for comma. We have said is CB plus BD. You will still get the same answer. So what we are going to do, I will use CO plus OD, the first root, and that one will give us CO we found is 2. Actually, OC we found OC as 2 over 3B. But we are now moving back against the vector. So it will be negative 2 over 3B. Because OC is 2 over 3. Then we are going to add OD. And on adding OD, we found OD was 2 over 3A plus a third B. Now we shall find here you are going to have 2 over 3A minus a third B. Because if you take 2 over 3B, which is negative, and you add to 1/3 B, you will have a negative of a third B. So we have found that CD is equal to 2 over 3 or 2/3 A minus a third B. Now we are going to find DE. Finding DE, we need to join D to E in such that we have. So on joining D to E, we shall find that EDC are straight line, but we need to find DE. So finding DE can be found in 2 or even 3 ways. One, you may decide to go DO plus OE, or DA plus AE will still give you the same answer. So you can take DO plus OE, or find using DA plus AE will still give you the same value. But to me, I do prefer to take what you already have. Like there we have OE and we all have OD. So we can use OD and OE to find DE. So if we have that one, we are going to use that. And we know OD we already have as 2/3 A plus 1/3 B. But if we need DO, then we have to go against the vector. And going against the vector means we are negating OD. So we shall have negative OD, which will be negative OD is 2/3 A plus 1/3 B. Then we add to OE, and OE we had as 4 over 3A. Remember, these are our vectors in that case. So on doing that, we are going to have negative 2 over 3A if we expand the bracket, and then we add to, actually we shall subtract because it's a negative outside, so it will give us negative 1/3 B plus 4 over 3A. In that case, if you add that collect terms, you will find negative 2 over 3a plus 4 over 3a. You are going to have 2/3 a of vector a, then you subtract 1/3 b. That is what we have as dE. So meaning dE is equal to 2 over 3a minus 1/3 b. And our OD, actually 2 over 3a minus 1/3 b is the same as CD. So meaning CD is equal to DE. And as you can see from our construction, almost we guessed the right thing. Because you can see it's almost the same. But that is from the working tells us that CD is equal to DE. So that is what we have found. Now the next question was to find CE. CE. To find CE, CE can be found by taking either CO plus OE, or you move just, that's the best method to go there. So we shall take CO plus OE, and you find that one will be, but since you have CD, you have DE, you can still add them together. So meaning you can still even take CD, then you add to DE. We still give you the same value, but let's use CO plus OD. So CO is negative 2 over 3B plus OE is 4 over 3A. So you're going to get, this one is going to give you 4 over 3A minus 2 over 3B. And in case you work this by taking CD, remember CD is 2 over 3A minus 1/3 B. Then you add to DE, and DE is also 2 over 3A minus 1/3 B. You will still get 2 over 3A plus 2 over 3A. You are going to get is 4 over 3A. Then 1/3 B minus 1/3 B, you are going to get minus 2 over 3B. So still the same value. So meaning whichever method you take will still give you the right answer. So we have found CE equals to 4 over 3A minus 2 over 3B. So that is how it is. Then the next question says, show that C, D, and E are collinear. In order to show those points are collinear, remember the law of collinear. One, they are on a straight line. And as we can view, C, D, and E are on a straight line. Another thing is that they must be, one of the points must be a common between the two of them or three of them. And then if you take, for example, CD should be a scalar multiple of DE, or if you take CD should be a scalar multiple of CE. That is what it should be. But remember, one point must be a common point between what you are finding. So let's go on and find or show that the points are collinear, because we can see they are on a straight line. Now we can try it in several ways. We can take CD be equal to KBD, DE actually, DE, or we can do it in this way, in that we say CD is equal to KCE, in order to satisfy that rule of parallel vectors. So we shall start with this, and we shall take CD, and CD we have here is 2 over 3A minus 1/3 B. And then this one should be equal to KDE, and KDE, DE we have already, DE we got 2 over 3, so it will be K into 2 over 3A minus 1/3 B. That is what we had. Now after getting that, what you do next, you come here and do 2 over 3A now will be equal to 2 over 3A minus a third b is equal to 2 over 3 ka minus 2 actually minus a third kb. And on doing that, we shall now compare the coefficients. Since we have a common in both and b, we shall compare the coefficients here and say actually 2 over 3 a is equal to 2 over 3 k a. And also we have another one here, which is negative a third b is equal to negative a third kb. So on doing that, we shall find out the value of k. So here we can cancel a by dividing both sides by a, and we shall find 2 over 3 is equal to 2 over 3 k. So to find the value of k, we are going to multiply 3 over 2 on both sides, and we shall have 2 over 3 multiplied 3 over 2. We are going to find k is equal to 1. Let's see if the other methods will give us the same value. Divide both sides by b to obtain k, and if you want k, you will now multiply by, in order to get k, multiply both sides by negative 3 over 1 or negative 3, multiply both sides by negative 3, and you will find negative a third multiplied by negative 3. You are going to have k is equal to 1, because 3 and negative 3 will cancel to give the negative 1, and if you multiply by negative 1, you are going to get 1, positive 1. So in both cases, we are finding k is equal to 1. So meaning that CD is equal to DE, and we can find that the scalar multiple there is 1. So they are parallel, and also D is a common point between the 3 points. So meaning that these points C, D, E are collinear. 1, they are on a straight line. 2, D is a common point between them. And 3, CD is parallel to DE because it is having a scalar multiple of 1 to each other. And that's what we do. So showing that 3 points are collinear. You can use even the other one, and that one I leave it to you to do, because we have CE. We have CE. I think we wrote it somewhere. This is CE. So CE, you will replace the value of CE here, and CD, we have CD is there, 2 over 3a minus a third b. After doing that, you find k. After finding k, then you work out the value of k. After finding it, you will find, if it is common, k is common in both ways of a and b, then you will find out that CD is a scalar multiple of CE, such that now when you do that, it will have a common point which is C, and since they are on a straight line, you will find they are collinear. That is how we do work out collinear points and collinearity of points. Next, we shall see how to find a scale or ratio as we move on. In case you have been given the points and you want to find the ratio in which they are divided, we shall see next on how to do that. But right now, understand how to find the collinear points. And if you have been given a triangle in any circumstance, or a parallelogram, or given rhombus or what, but if you have some points given this, I think by now you can prove given points are collinear by the 3 ways. 1, they should lie on a straight line, they should have a common point, and be parallel to each other by having a scalar multiple. Now let's move on and see how we can find proportional division of a line. And we shall start with internal division. Under internal division, I start by giving out a given length. Here I have a 1 meter line being divided into several measurement of 10 centimeters each. So I shall give out the total length of that ruler, and will be like LM, and then give let's just take like P. Let's find the internal division of that line with regarding the 3 points, which is LPM. So give the internal division of the points there in which P divides line LM. So in place where you are giving the internal division of LM with regarding of P, then we shall say LP to PM will be equal to LP to PM is equal to, that one means that line, actually point P divides line LM in the ratio which we are about to give, that is. So from there to P we are having 7 divisions, and then from P to M is 3 divisions. So it will be 7, 2, 3. That is 7, 2, 3. So the internal division of line LM by point P is 7, 2, 3. And that is how we can find. What if we add another point Q here? Find the internal division of point Q to line LM. Then you will find LQ to QM will be equal to 3 to 7, as you can see. But find the internal division of point P to line QM. To line QM now will change. QM to line QM now will be QP to PM will be equal to, now you will work out 1, 2, 3, 4, that is 4 division 2 to 3. So point P divides line QM in the ratio 4 to 3. Now if you may introduce another point as K at this point, and you'll be asked to find the length or the division in which point K divides line QP, then it will be QK to QP, QK to KP is equal to 2 to 2. So that is 2 to 2, which can be simplified further and you find it will be 1 to 1. But this one is the best ratio to give, 2 to 2, because it's the measurement which we are having there. So to find the division in which K divides line LM, then it will be LM LK to KM is equal to, actually you will find is 5 to 5, which is the same as 1 to 1, but you will give 5 to 5 because of the measurement which we are using. So there we can find that in case you are being asked to find internal division of any given line, you take the point which you are being given to be in between the line to be divided. And that line must be divided using same interval, that is equal intervals, in order to find the internal division. So that is how we do give it. And I would like you to give me in which ratio does K divide line LP. So you will find out in which ratio does K divide line LP. Now let's consider an external division of a line, and under here we have a similar line to that of internal division I have drawn here. We shall use it to determine external division of given points on this line. Under external division, you will find that you have 2 points on the line, one lying outside of the given scale of interval, but the interval of division between the 2 or 3 points is actually the same. So for example, we may have points like A and B and have another point K. So you may be asked to determine the ratio in which K divides line AB, or in which ratio does line AB is divided by K. So that one you will have to do in that direction. You will take AK to KB or to BK, AK to BK will be equal to the ratio of, since it is line AB, then the total ratio is A to K. So that is, as you can see, it's 10 divisions. Actually, it's 10 divisions. So it will be 10 division 2. Now the line is AB. Whatever we are having here is outside our interval which we are doing. So that one will be negative regarding to this one. We are going a negative direction to what we have here. And if that is the case, we are going to find that one will divide this one in a negative of. So it will be to negative 6. So that is how it is given. So AK divides BK in the ratio of 10 to negative 6. The same we may have another point at this point, let's say point M. So we may be able also to calculate in which scale ratio does M divide line AB. You will find out that it will divide line AB in the ratio AM to BM as it will be, it is 7 to negative 3. Remember, it is negative because it is outside the scale of interval. So if you want to get the actual measurement, then you will take 7 minus 3 and you'll find the actual measurement here is 4. The same applies to this, you will get 4 intervals. So the same can apply in what ratio does K divide line BM? So you will find it will divide line BM in the ratio BK to MK as is equal to 6 to negative 3. That is what we will have. So that is how we do give external division of a line. After that, we are going to see much more, and we shall consider an example here. And we are going to work out an example on a point P divides a line AB in the ratio 3 to 2, and a point Q divides a line AB externally in the ratio 7 to negative 2. Draw a sketch showing points A, B, P, and Q, hence determine the ratio in which Q divides line PB. So we are going to do that, and we shall find out that we have been given a line AB, so meaning P divides AB in the ratio 3 to 2, so it will be is equal to 3 to 2, and P, we have another one as Q, so meaning AQ to BQ is in the ratio 7 to negative 2. So I have drawn a line here, and with this line we are going to sketch what we are having there. So we shall start with our A here, and A to P is 3 division. The line is divided into equal interval, and A to P is 3 division. So you will count 3 division and find your P, and P to B is 2 division. So from P to B is 2 division. That is what we shall have. Then after getting that, that is what we have as 3 to 2. So you will find that actually point P divides line AB in the ratio 3 to 2. So we have another one, point Q, which divides line AB in the ratio 7 to negative 2. In that case, we are going to have AQ 7 division, meaning from A to Q we have 7 division. So it will be 7 division, and also we are going to have B to Q will be negative 2. So what we having is A to B. So meaning from B to Q, you will subtract 2 from what you had earlier. That is 7. 7 minus 2, actually you will get your B, is 2 steps behind that Q. So that is negative 2, as we can see. So that is how that one is given out. The question was, determine the ratio in which Q divides in which Q divides PB. So PB we have is here, Q is still outside. So you will find that Q divides line PB in the ratio PQ to BQ equals to PQ to BQ, it will be 4 to negative 2. And that is how you give it. You can give 2 to negative 1, but because we are using this scale interval, it will be 4 to negative 2. With that, we have come to an end of proportional division of a line, and I think you can use that to divide any given line either externally or internally. Next, we are going to see the ratio theorem, and we shall start with the internal ratio theorem. Now let's go on and find our view about the ratio theorem. And under ratio theorem, we are going to see internal ratio theorem, and we shall start with this internal ratio theorem, and I have one of the example here, of which is similar to a triangle. Let this be a triangle of origin O, then A, R, then B, in such that OA is vector A, so meaning that is in that direction, ORB, vector R, and OB, B vector small b. And R divides AB in the ratio 5 to 3. So if that is the case, R here divides AB in the ratio 5 to 3. So if that is the case, you are being asked in the positions of A and B, find the position of vectors of R. Find the position of vectors of R. So if that is the case, we can do that internal division. That is what we have as internal division. So when we do that, we are going to have, if we want R, or R actually, we can find it, which is R. We can find it in different ways. We can take OA plus AR, or we find it by taking OB plus BR. Remember, this one is here are vectors. You can either indicate it by that way, or you write it bold, in bold letters and capital letters. So that is what we refer to as vector. So OR can be determined in that given direction. So you can either move this direction then to there, you will find your R as the final destination, or you move using the other route, that is OB, BR, you will always arrive at R. So we can do it in that case, but here we are going to take OR will be equal to OA, which is A, plus AR. But AR, we have been told, is 5. R is dividing line AB in the ratio 5 to 3. So meaning, if we want to find the place from A to R, we need to take 5 over the total ratio of the line, and that is of 5 over the total ratio is 8. Then we multiply by the line AB in the way we were moving. That one, we were coming from A to R. So it will be AB. So that is what we have. And remember, this AB here, we shall have AB. AB is the same as taking, actually AB here is equal to AO plus OB. And that one is going to give you negative A plus positive B. That is the reason you are moving against the vector and going towards the vector. That's why we have a negative and a positive. So in that case, we are going to have that. So in place where we have AB, we shall replace with B plus minus A. That is negative A plus B. So for that case, we are going to have A plus 5 over 8. Now this one will be B minus 5 over 8A when we open the bracket. So that one is going to give us If you take A minus 5 over 8, you will remain with 3 over 8A plus 5 over 8B. Where you can factor out? No, it will remain that one. So we are having 3 over 8A plus 5 over 8B. That is what we are finding as what we are having there. So this is our value for that case. OR can be represented in that case using the first method, which is OA plus AR. Anyway, you can use the second method, which is OB plus, that is OB, actually it's OB. Let me do somewhere else which is visible. So we have found OR, the first OR we found is 3 over 8A plus 5 over 8B. Let's use another method and see if we get the same. So we shall find out that using the second method, OR can be found by taking OB plus BR. And that one is going to give you OB is equal to vector B plus BR will be 3 over the total ratio 8 of BR and B of BA, of BA. So it's 3 over 8 of BA, and that one is going to give you of BA. But remember, BA here is equal to negative B because you are going against the ratio, that is BO plus OA, that is negative B plus A. So this one will give you, now in place of BA you will write that, and you are going to have B vector B plus 3 over 8 A minus 3 over 8 B. This one is going to give you, if you move on, you will have 3 over 8A, B minus 3 over 8, that is 1 minus 3 over 8, you will get plus 5 over 8B. Plus 5 over 8B. And if you may view out, you will find you are having the same value. So meaning, regardless of the way or route you use, you will get the same value. So that is how we do find internal division of a given, that is internal division ratio theorem. So let's go on and see external division. Now let's go on and find or view about the ratio theorem. Small letter b, and OP is small letter p, that's the vectors. So you may be issued with P divides the line AB externally in the ratio 5 to 1. 5 to 1. If you have been told it divides that line externally in the ratio 5 to 1, then it means that you are going to have the total ratio from here to there is 5, but P is one scale division outside of B, outside of line AB. So meaning the total divisions in the present of interval of A to B will be 4. You will take 5 minus that one and you get is 4. For B to P will be 1. So 5 here indicates the total ratio. And then there is that you may be told that P divides line AB in the interval or in the ratio 5 to negative 1, then you will know that one is an external division. But sometimes, like what we have been told, P divides line AB externally in the ratio 5 to 1, then that one you know, the ratio is 5 to 1, but it is externally. So meaning 1 is externally and 5 is the total ratio, so you will find it that way. But if you are not mentioned that name externally, no, the scale will be given as 5 to negative 1. So that is how it is being given. So we are going to work out this, express P in terms of A and B. express P in terms of A and B. To express P, we know is OP. P is equal to OP. And to find that OP, we can use two ways. One of the way may be OA plus AP, or OB plus BP. Any of the way will give you what you want. So if that is the case, we shall start with OA, and you can see OA is equal to A. So that is A. So you will have that one as A, vector A plus AP. AP we have 5, actually is 5. The total ratio is 5. But we have 5 of that line which we have been given for case. Now let me wrap this first for explanation. You will have that we are having A to B, which are only in terms of A and B. P is not present in this A and P and B. So what we have in there, we are having a total line AB, which we can calculate and find out that AB is equal to AB is equal to AO plus OB, which is given by AO is vector A plus OB is vector B. So on doing that, that is what you will get. But remember, AO is against the vector, so you will find that AO is negative of that one. So you are going to have B minus A. That's what is what you have. So meaning that 4 here is representing B minus A. Actually 4 represents B minus A. So from there we can now find out the positional vector of P in terms of A and B. So we can now come and say, we want to find the positional. Now we say we shall take root A, which is OA plus AP. But remember the total ratio there we are having 5, because we shall add one external division which will make it to be 5. But the present of the vector which we have, which will resemble B minus A, is represented by 4. Because this AB is what we are having as B minus A. And that one is of ratio 4. So the total ratio of that will be 4. So it is 5 over 4. And then we shall multiply by this 5 over 4 of AB. So it is 5 over 4 of AB. So meaning that we shall have A plus 5 over 4 multiplied by AB. AB we have found is B minus A. So this one is going to give you A plus 5 over 4, B minus 5 over 4, A. On doing that, we are going to have 5 over 4, B. Then A minus 5 over 4, you are going to get minus a quarter A. That is the value of P in terms of B and A. You can use the other method, that is OB plus BP. Let's decide to use OB plus BP in order to get OP. So we shall have OB is vector B. So this one will be vector B plus BP. BP will be 1 over the total ratio of vector. And what we shall be taking here is the total of what we have. So the total here will be equal to, here is AB, and AB is 4. So it is 1 over that total, which is 4. And we shall find, we shall multiply by AB. So this one is going to give us, we shall find is, so you will find this one is going to give you B plus a quarter into AB, but AB here we are having not AB, but it will be B. Actually it's A, B. So you will have as B minus A. So that is B minus A. So we are going to have, we do past that. So it is B plus a quarter B minus a quarter A. And this one you are going to have, if you take B plus a quarter B, is going to give you, B is the same as 1. So 1 plus 1 over 4, you will get 5 over 4. So it will be 5 over 4B minus a quarter A. And let's view. You will find that your answer is similar. So no matter the way you will use or the root, the answer will always be the same. And we have seen that is how we do external division of a given line in a given dimension. So we are going to consider a general case where the ratio may be given in terms of m and n. This is my triangle here, and in case I'm having line S or point S dividing line AB in the ratio m to n, then I can give the positional vector of S in terms of A and B, such that we can have OS equal to, we can do it in two ways, that is OA plus AS, or we do it by the way of OB plus BS. Still we can find the same answer. Let's start with the first one, that is OA, and OA we have as A, so it will be OS is equal to A, which is OA. Let's just give it out all. So it's OA plus AS. Actually we have it here, so I'll just give the values. OA. So we can give OS as line AB is equal to, we shall find out AB. So we can say line AB is equal to, AB will be AO. AB is equal to AO plus OB. So you will find out that AO is equal to negative A because it's against the vector, and OB is positive B because it is in the way of the vector. It's according to the vector. So you will have that one. So we can write that as A plus M into M plus N of that one, which is B minus A, and this one is going to give us A plus M, my M into that you will have M, actually it's M over M plus N, B minus M, that is M over M plus N A. So that is what we are having up to that point. So after getting that, we can now factor out what we have. So that is A minus M, MA over M plus N, plus M over M plus NB. So that is what we are having as A, M, that of A. So in that case, we shall have A outside, and we are going to have 1 minus So after getting what we have here, which is A into 1 minus M over M plus 1 plus N of A, that is, and then that of B like that, we can continue and expand what we have here. And on doing that, we are going to have this one here. As we can see, this is a whole number. So we can find the LCM as M plus N, and you will find 1 minus M over M plus N. If you find the LCM will be M plus N, and you will work out and find out that this one will be over 1. So it will enter there M plus N. And M plus N into N plus N you will find is 1. So if you multiply by 1 and by M you will get M. So you are going to subtract M, and you will find out that this is gonna be M plus N minus M, and you will find the m will cancel with the m, and you will have that one is equivalent to n over m plus n. So meaning, whatever is in bracket here, 1 minus m over m plus n of a can be replaced by n over m plus n, as we can see by working. So meaning here, meaning we can find it out that our there, whatever is in bracket is replaceable with n, m plus n of a plus m over n, m plus n of b. So this here is what we call ratio theorem. That is the ratio theorem, and that is what we can use in calculation of S with reference to A and B, where the ratios are m and n. So you can see what happens if you have n here and you have m here. In case you want to find S in terms of A and B, then you can take S is equal to, that is OS. OS will be equal to n over the total ratio, which we have said is n over m plus n. Then you multiply by the side of A, which is opposite to that, which is this side. So it will be multiplied by A. That is what I mean. You take this n, you multiply over the total ratio, then you multiply by this side. And then if it is for B, then you take m over the total ratio, you multiply with the side which is on the opposite side, which is B. That is how it is found, and is known as ratio theorem. So theorem states that the proportional or the positional, actually the positional vector S of a point which divides a line AB in the ratio m to n can be given by that formula which we have. S or OS can be given by n over m plus n A plus m over m plus n B. That is now how to find or what the ratio theorem states. Now we shall use that theorem and find out much more about how to apply them in our evaluation. But remember one thing, that if you take this ratio here, that is n over m plus n, you add to m plus n, you will find 1. Because all of it, if you add, you will get a whole number 1. So that is how we have handled that, and we shall be using this ratio theorem here to calculate our daily numerical problems involving ratio theorem. So we are going to see one of the example here and work it out. An example is a point R divides a line QR. We have a triangle actually. Let me draw first. A point R divides a line QR externally in the ratio 7:3. If Q and R are positional vectors of point Q and R respectively, find the positional vector of P in terms of Q and R. So we have been told it divides that line QR in the ratio 7:3 externally. So meaning the total ratio is 7, but here will be -3, so it is 3. This one will be 4. So that is the ratio in which it divides. And from there we shall be using, so we shall even use the total ratio as it is. So we shall just write as we have been told. So it is -3 here. Here will be 7. 7 to -3. Let's take it that way. We shall use the ratio as they are, so that is 7 and -3 and Q and R. So we need to give the positional vector of P in terms, that is, give that of P in terms of Q and R. So what we are going to do, if we want to give that one in terms of Q and R, we are going to take, using the ratio theorem, we said if you take n over m plus n of A plus m over n plus m plus n of B, you will be getting, in case it is here, so that is of S. So that case applies to what we have here, and if that is the case, our case here now we shall replace this one by P, and here B will be replaceable by R, and our A here will be replaceable by Q. So N will be -3, so we shall take, using the theorem, -3 over total ratio will be 7 minus 3, so that is 7 minus 3. That's the total ratio, because if you take 7 plus -3, you will get 7 minus 3. And then we multiply by Q, is what we shall have at the other side. And then we are going to add to M, and M is 7, that is 7. And then we shall take 7 over the total ratio is 7 minus 3. And you will find you are multiplied by R. So this one should give you whatever you are seeking in P terms. So doing this, you are going to get negative, actually it's negative, you will get -3Q over 4, -3 quarter Q plus, here you will have 7 over 4 R. So that is what we have as P. So we have just found P in short terms using the ratio theorem, and that is how you do find it in just using that shortcut. That's the ratio theorem which helps us to work out the given sums using that problem. So that is how you can incorporate. You can find out some more several given examples of the same way and work out. We shall see on another one and see how to calculate the ratio of those given parts. I have a triangle here, and in the figure below us we can see it. OA, we are having OA, O, then A, and this one is B. So OA is A, OB, OA is A and OB is B, so here is B. And a point P divides OA, a point P divides OA in the ratio 3:1. So a point P, so this is point P here, and if you join to B, you will get that. Divides OA in the ratio 3:1, and then another point Q divides AB, so this one is Q, and divide that line AB in the ratio 2:5. That is, here is 2, here will be 5, 2:5. So that is how a division takes place. If OQ meets BP at M, OQ means BP at M, determine OM to MQ and BM to MP. Here we need to see how we can determine these given points. Now, having them like that, and we are being given, so this one we know this is vector A in that direction, the other one direction. So we need to find one of the vectors using two different ways. Let's find OM. We know one thing. To find OM will be equal to, we can assign this side, let's say this line OQ be in the ratio K. Now, because this is K, and we said if you take the ratio theorem, you take the coefficients of A and B, if you sum them, you will get 1. Then it means here will be 1 minus that K. Now, after doing that, we know that, and the other line will be, let's say this one be N, in such that if this is N, then this one will be 1 minus that N. So in that case, we can now work out and find out what we need. So I want to find OM in two different ways, and if that is the case, I can use OP and then I add it to PM, or I use the way OB, then I add BM. That is OB plus BM. Or I can decide to go directly. OM to be K of OQ. So I will start with that one. OM equals to K of OQ. I just start with that. That is the best. So on starting with that, we shall have that if you just move directly from here to here, you will have K of line OQ. And remember, OQ can be given by OQ is equal to AOB plus BQ, or OA plus AQ. We'll get the same value. So that is, then use OB plus BQ. If that is the case, that's what we are going to have. So after that, we have OB will be vector B, and BQ will be 5 of the total ratio, that is 7, multiplied by 5 over the total ratio multiplied by BA. And BA we are having BA as, actually BA, we can still do it further and just take 5 for that, but let us just take that. That is, BA will be BO plus OB, that is negative B plus A, and you find this one is gonna be B plus 5 over 7 A minus 5 over 7 B. So on doing that, you are going to have, this one will give you B equals to, actually if you do that one, you are going to get 5 over 7A minus 5B plus B, you will get plus 2 over 7B, of which this one can be still found directly by just using the ratio theorem, that if you want to find the coordinate of actually the position of vector of Q with reference to this using the ratio theorem will be 5 over the total ratio, which is 5 over 7. Then you multiply the side which we have been given, that is A, the opposite side. Then you add to 2 over the total ratio 7. Then multiply by the other side which is B. And you find this value and here is still the same. So that's just tiring you, but that's the best method to use. So we have found that OQ is 5 over 7A plus 2 over 7B. I'll replace here what we have, that is 5 over 7A plus 2 over 7B. So after getting that, that is one method of just going directly, that is OQ. So I shall go with the other method, that is OB plus BM. So going that way, OB, I will find that OM2 equals to, this was 1, OM2 will be OB, and that one is B, plus now N, and N will be N over the total ratio is just 1. So it is N multiplied by what I have is BP. And BP here can be obtained by taking BP is equal to, actually we want to use the ratio theorem to find BP, and BP will be N multiplied by this one, what we shall be having here, and it will be 3 over the total ratio, which is 4 times A, so it's 3/4 A. So BP will be N multiplied by 3/4 N, so it's N multiplied by 3 over 4 of A, and we are going to have that way, because P is dividing line OA in the ratio 3 to 1. Total ratio is 4, and if you want to find that what is OP, you will get 3 over total ratio of 4 divided, and then you multiply by A. So n multiplied by that, we are going to get that. And then 1 minus n, we shall add to 1 minus n of 1 minus n multiplied by B. So that is what we are going to have as BP. So actually not BP, but that of M. That is of M actually. So we saw using OM1, that is OM1 using the method of K of OQ, we found that is what is there. But if we use another method OM2 and we use a method of OB plus BM, we shall just be finding the coordinates of M with respect to n and 1 minus n, and you will find that is found by using that method. So meaning this is what we shall get if finally. So we are having OM2 is equal to what I have here, and OM1 is equal to what I have there. Still you can calculate directly, and you will find if you calculate directly, that is OB, B plus now n of the total ratio is 1 multiplied by line BP, you will still get the value as this. But to avoid that, you just use ratio theorem. So after getting OM1 and OM2, you will now equivalent or equate the two to find the number n and m. On equating the two, we shall find K, actually let's just say 5 over 7 Ka plus 2 over 7 Kb is equal to 3/4 Na plus 1 minus Nb. So this is what we do find as we equate. So we shall equate the coefficients of the given identities or given letters. So we shall have 5 over 7 Ka is equal to 3 over 4 Na. So we have 5 over 7 K is equal to 3/4 N. The other one is 2 over 7 Kb is equal to 1 minus Nb. So if we equate, we are going to have 2 over 7b, 2 over 7k is equal to 1 minus n. So that is what we shall find, because a will cancel out the same to b. Now let's work out that. From those equations, we need to find the value of k and n. And in order to find, we need to find by using simultaneous or working them simultaneous. And working simultaneous, it means we are going to make them be an equation that is 3 over 4n equals to 0. And this one on transmitted to other side, we are going to have 2 over 7k plus n is equal to 1. So if we need to solve simultaneously, we need to make them be in a way that we shall find it easily. So we shall multiply by 28 by 28 by 28 to eliminate that fractions, and this one by 7. So you will find this one here is going to give you 20k minus 4 into 28, 7 by 3, 21, and is equals to 0. And here we have, you multiply by 7 to remove the fraction. This is 2k minus 7n, actually plus 7n is equal to 7. So on doing that, we are going to have, here you will get, to eliminate here, you first need to make them one of each to be eliminatable. And if that is the case, let's eliminate k, and on eliminating k, we shall multiply this one by 10 in order to make it eliminatable. So that one will give us, we are going to have, the other one will remain 20k minus 21n equals to 0. And this one, 10 multiplied that, we will get 20k plus 7 by 10, 70n equals to 70. So we are going to subtract, and on subtraction, we shall find 0 minus 70, we will get negative 70 is equal to 21 minus 70, you will get negative 91. So this one is going to give you negative 91, and this one will cancel out, you get 0. So you are having negative 91n. So meaning that n, 91n, negative 91n equals to, is it negative? Yeah, negative 91n is equal to negative 70. So if you want the value of n, you need to divide both sides by negative 91. Both sides by negative 91. You will find n equals to, now we are finding n equals to 10 over 13. Now we can substitute this in any of the equation there, and we shall find, in case we take the first equation, we are going to have 5 over 7k is equal to 3 over 4, but in place of n, we replace with 10 over 13. So we are going to multiply by 10 over 13. So when we multiply, we are going to have 5 over 7k is equal to 30 over 52. Now to get the value of k, we are going to multiply both sides by 7 over 5, the reciprocal of the coefficient of k. So we shall have k equals to, multiply both sides by the reciprocal of the coefficient of k, and we are going to have 30 over 52 multiplied by 7 over 5. So we shall find, we are going to have so k is going to be 21 over 26. So we have found in both cases the value of k and the value of n. Even if we substitute using the second equation, we shall find the same value. So what we shall have here, we have found n is equals to 10 over 13. Remember here in ratio theorem, we say the denominator represents the whole sum of the ratio. So meaning that 13 is the whole sum, but 10 is the part of that line which is represented by n. So meaning in case here is n, then n will be 10 over the total ratio which is 13. So meaning this one here will be 10, n is 10 here, and then the whole line is 13. So meaning the remaining will be 13 minus 10, and you will get this side, instead of saying 1 minus n, shall now be 3. Or you just take 1 minus 10 over 13, and you will find is 3 over 13. If you find that ratio theorem, you will find that this side will be 3 and the other side will be 10. The same apply to this. We find this k, this side will be 21 over 26, meaning that k alone will be 21. The total ratio is 26. If you subtract, you're going to have this side here being 5. So meaning that if we were told to calculate the ratio of OM to MQ, OM shall be 21 and MQ is 5. So meaning this ratio is amounting to 21 to 5. The other one shall now be BM to MP is equal to the ratio of 10 to 3. And that is how we do calculate the ratio using the ratio theorem. You can use it to evaluate any kind of given equation. Remember, after getting the two equations there, which is in that case, don't solve using substitution there. You first solve them using elimination method, then you will substitute later. Consider application of vectors in geometry, and our first session we are going to consider how it is applied in parallelogram. For instance, here we have one part of the parallelogram as this, which has the vertices A, B, C, and D. We are required to show that the diagonals of this parallelogram intersect each other. So what we shall do, we are going on construct those parallelogram, that is joining the vertices diagonally, and let the point where they intersect each other, let that point we call it as T, such that if we take a ratio of it, in case of this, we say let from A to T be like, we can call it, let's say K. So meaning that if it is K, the whole ratio should amount to 1. So meaning this one will be 1 minus K. The other side here, let it be N from B to T be N, such that from T to D is a ratio of 1 minus N. In that case, we can say, in this case, since this diagonal, this line here, we can give it B vector A, and this side here B vector B, such that if it is a parallelogram, we are going to find that AB is equal to BC. So meaning this side here will also have B. The other side DC will have, DC will be equal to vector A, which is AB. Now from there, now we can say we are going to find AT in 2 dimensions. The first dimension, we can also find it in 2 different ways, but we are going to consider the first one as AT. Then we can also consider another person passing through ABT. You will still arrive the point ABT or ABCT. You will still find the same point. So it doesn't depend. It doesn't matter the route which you take, so long as the destination is still the same. For my case, I will consider this, the first route, as AT, which I will take just straight as AT. So meaning it will be K of the total ratio. So it will be K multiplied by this vector from A to C. So will be K of AC. That is my first route. My second route, which I will now take, I will decide to take the route of, to get AT, I'm going to take this other route, which is AB. Then I add another route which I will take as BT. Still, I will arrive at the same point. Now I'm going to consider the first route, and that is we are going to find AT in the first route, but we know it is K of AC. So what I shall do now, I will take AC first and find out what is vector AC in case I go directly from A to C. I'm going to get AC will be equal to AB plus BC. And in that case, I'm going to have AB is vector A and BC is vector B. So meaning that AC is equal to A vector A plus vector B. So meaning AT of 1, I'm going to get it as K into bracket vector A plus vector B, since that is AC. So we shall have that one, and we shall say this one here, I'm going to have it as KA plus KB. That is what I find AT in the first way. The second one, I'm going to get AT2 will be equal to AB, and AB is vector A plus BT. And remember BT here is N of BD, so it will be N of BD. But remember, to find BD is equal to BD, it is equal to negative of the vector AB plus AD. So it shall be negative vector A plus, now the other one is positive B. Because you are going against the vector, so it shall be negative. So we are going to have that way. So meaning that our AT2 is going to be equal to AT2 is going to be equal to vector A plus n of negative A plus vector B. So if we do that, if you open the bracket, you are going to have vector A plus NB minus NA. So if you collect the like terms together, we are going to have this one as A into 1 minus N. I'm taking A minus NA together, so if you factor out A, you're going to find A into 1 minus N, then plus NB. Now we have found our AT in two different ways. Now we want to solve for the value of N and also solve for the value of K and find out what we shall get. On solution, we shall now say, since we have AT1 as Ka plus Kb and AT2 as A into 1 minus N plus NB, we can say, since it is at destination T, meaning AT1 and AT2 are similar or are equal. So in that case, we are going to equivalent the two, and we shall be now comparing the coefficient. So meaning, if we compare the coefficient, we are going to have Ka here being equal to this here, which is A1 minus N. So meaning A shall cancel out, and we shall have K is equal to 1 minus N for this case, because both of them are having 1 minus N, K are the coefficients of A in both cases, respectively. So we are going to have another coefficient which is KB and NB, meaning N is the coefficient of B in AT2 and K is the coefficient of B in AT1, meaning both of them are equal, so it shall be in that direction. So we are going to solve for the value of K and N, and we shall solve it in simultaneous ways. So we shall have K minus, now if you take this N to the other side, we shall add N in both cases, so in both the sides of the equal sign, and we shall have in the like that. So we are going to have the other one will be K minus N is equal to 0. After forming that two simultaneous equation, now you solve them and find the value of one of them. So this one here, we shall solve using subtraction. So in that simultaneous case, but we shall subtract in case of finding one of the unknown terms. So if we shall add actually, we are going to add, and if we add, we are going to eliminate N. But if we subtract, we are going to eliminate K. For this case, I'm going to add, and we shall find here we are going to have 1. And if you take positive N, you subtract N, you are going to get 0. And K plus K, you are going to get 2K. Meaning 2K is equal to 1. So we shall have K as a half. I think you have got me right there. So K we are going to have is as a half. But remember here we have said that K is equal to N. So meaning if K is a half, then N is also a half. That indicates that N is also a half. So in this case here, if we replace, we shall find that in case of K here, we are having, if this side here is a half, so they are in the ratio of 1 to 1, 2, 1, because the whole line is 2, and if this one is 1, the denominator implies that the whole line should be 2. So it will be 2 minus 1 you will get. Here is 1. The same applied to here is 1 to 1. And that implies that AT is equal to a half of line AC, as we have seen from this here. K is a half, so it's a half of line AC. The same applies to BD. So we are having that BT actually is equal to, we found N as a half. So it will be a half of line BD, and that is of line BD. So that is what we have found, and we can see that both of these sides are that way. So meaning the point where they intersect, this is 90 angle, this is 90, this is 90, this is 90. So the diagonals intersect each other at right angle. And we have seen on intersection, each side remains with a half. In our next section, we are going to see how we can let's consider a kite PQRS, that is our kite, and A, B, C, D as our midpoints of that given respective sides of that kite. And if that is the case, and take RS as the side being C and the other one being D, A, B respectively. So you will find out that this one will appear to be in that direction. So we needed to find what A, B, C, D represent, or how does it come as a rectangle. So we shall find that in case of that, you can find QS. Let's find SQ first. We shall find SQ. Our first is to find SQ. And if we find SQ, giving it in this kind, so we are going to find SQ depending on the upper side. So that is SQ equals to SP plus the other one is PQ. So we are going to have SP plus PQ. You will have SP is D plus PQ. We are having PQ as A, vector A. So if that is the case, that is what we are going to find as SQ. And we can also find DA, as DA will be obtained by taking DP plus PA. And that one can be found by taking, actually here, since we have been told this is the midpoint, D is the midpoint of PS, it means that this is a half, this is a half, they are in the ratio of 1 to 1, so meaning it's a half. Here is a half, also this is a half. So we shall have found that that one will be given as a half of, if it is D, it will be a half of D plus a half of the other one, which is A. So we have found this one is a half D plus a half A. So you can view, if you do a relationship between a half D plus a half A with D plus A, I mean the relationship between DA and SQ, you will find out that they are a half of each other. So you can find that SQ is equal to 2 of DA, such that it implies that DA is equivalent to a half of SQ. That is what we found by working. That is what it has shown us. So from there we can say this DA is parallel to SQ because it satisfies that condition that we have DA is equal to K of SQ, where K is a half. So it is parallel. And as we can see, this line here is parallel to SQ. Actually, SQ is parallel to DA. And from there we can also verify the downward part. That is, we are going to verify QS And QS can be determined using QR plus RS, or you can even verify RP or PR, still will give you the same value. So if that is the case, you are going to have QR plus RS will still assume the same because it's just the opposite side of the other, and this one will go on giving us B plus C. And if you find BC, you will find BC, since this one is in the ratio of 1 to 1, meaning that they are half a half. So B and C are midpoints of the given respective lines, and if that is the case, we are going to have a half B plus a half C. So implying that we are going to have BC equal to a half of QS. So meaning the two lines are parallel. This line and this one here, they are parallel. Still, we can still verify the others. We can verify PR. So let's verify that PR. So PR can be given by, I'm talking about PR. So you can find PR by taking PQ plus QR. That is PQ plus PR. And on doing that, what you are going to have is PQ is given by side A, and that one is going to give you A plus QR is B, so it will be B. But still we can find the midpoints A and B and find this side here. So if you want AB, it's the same as taking AB will be found if and only if you take AQ, that is AQ plus QB, and that one is given by a half A plus a half of this side is B. So that's what we have, and from there you can notice that the two here, one is a scalar multiple of the other, meaning that AB is equal to a half of PR. That is what we found. If you divide A by this, you are going to get a half. So we can find that AB is a half of PR, satisfying the condition that AB equals to K PR. So meaning that this line here, line AB and line PR, they are parallel to each other. So if they are parallel to each other, you will find that they are cutting this line here, which is parallel to the other at 90 degrees. So they are bisecting each other at 90 degrees, as you can see there. So if we found that this one is parallel to PR, then it means if this one is still the midpoint and this is the midpoint, then DC will also be parallel to PR by verification. So from there you will find at the point where the midpoint meets, that is the midpoint of B meets with that of A, then you will find out that line makes us an angle of 90 degrees. And therefore, if you have an angle of 90 degrees, that is a quadrilateral of each angle being 90 degrees, then we do call that one as a rectangle. So you will find out that whatever is represented inside is a rectangle. So that is how we can verify that one, application of vectors in geometry, and so on. We have so many of them. You can use vectors to verify different kinds of geometrical figures using vector. With that, we have come to an end of our topic today. That is vectors, and it is up to you to seek more problems involving vectors and handle them according to the ideas which we have used. Thank you for watching it. See you in our next video.